Okay, here's the second question of the mechanics section on the further paper. We're told an aeroplane is flying in the air that is moving due east at v meters per second. So that's the air is moving due east. Relative to that air, the aeroplane has a velocity of 90 meters per second due north. So immediately I'm going to just pause there and form a triangle. Okay, during a 20-second period, the motion of the air causes the aeroplane to move 240 meters due east. Find V. Now, if we look at the triangle, I can't find V yet, just using the triangle because I don't know the resultant. So it's the other information that's going to be the key with this. So we're told that during a 20-second period, the aeroplane moves 240 meters due east. So regardless of how far north it is moving during that 20 seconds, we know that every second it would move v meters per second to the east. So we can simply just look at the east direction. So in that direction, regardless of what else is going on, we know that they travel 240 meters in 20 seconds. So we can work out the velocity in that direction. It's like the river crossing questions. As long as you're using the right components, so if you're given a length in one direction, as long as you use that component of the velocity in that direction, you'll be getting the correct answer. So using v equals s over t, which we're always going to be able to use, there's never going to be an acceleration in these questions. V equals s over t, displacement 240 over 20 would give me 12 meters per second. So B says find the magnitude of the resultant velocity. So now we've got the second side to my triangle. I can find the resultant just using Pythagoras. So I've got the resultant. My hypotenuse will be 12 squared plus 9 squared, 90 squared all square rooted, giving me 90.8 meters per second. Then part C, find the direction of the resultant velocity, given your answers a three-figure bearing correct to the nearest degree. So I've drawn my triangle out again. This is my resultant, so the direction of the resultant. If I find this angle, it's nice and convenient, this one, because this angle here actually makes the angle with north, so therefore the bearing would just be that angle. So just doing basic trig, because I've got a right angle triangle. I've got tan theta is opposite over adjacent. Then inverse gives me 7.59, and for some reason they give you a mark for a bearing and rounding, which to be honest at A level it seems a bit ridiculous, but it should be the easiest mark, but it is most commonly a mark that people miss because you just don't read it, you just don't expect it to be there. So give that as a three-figure bearing correct to the nearest degree. So 7.59 would round to 8, and then a bearing needs to have the three figures, so if it's a single digit like 8 you'd put your 00 in front. Now the trick with these questions is forming that triangle to begin with. This was nice because we had due east and due north, we got this right angle triangle, but remember sometimes you're going to get a non-right angle triangle, so you're going to need to use your sine and cosine rule. Cosine rule you are given in the formula booklet, but sine rule you need to know.